Good morning, ladies and gentlemen. Welcome to KATSINA State Senior Secondary School Online Connect, powered by Exponential Computers. Physics lesson for SS1 students at first week. I, the presenter, Ismail Baraya. Okay, so for physics class or for physics lesson, here are some contents that we are going to talk about today. So one of the contents that we are going to talk about today is the concept of work, energy, and power. We also have interchangeability of work and energy, then followed by the determination of work, energy, and power. So we are going to start with the first one, that is the concept of work. Okay, so normally when we say work, most of the people used to do work. Some will say, I'm going to the work. Some will say, I have done that work. I have done so work, or different kind of works. So in everyday life, the term work is applied to any form of activity that requires the exertion of physical and mental effort. The effort that you use, your mental effort, your physical activities, that you have done them, that you do them with your force or with your power or with your energy. That is the work that you have done that requires the exertion of physical or the effort that you have done or that you use for that work to be done. So normally that is in our life. That is the work that most of the people or most of us that we are doing in our life. We have to use our energy, our effort to complete that kind of work. So here we are talking about in mechanics. We are talking about the work in physics. Okay. So normally work in physics is talking about the product, or is defined as the product of force and the displacement in the direction of the force. So when we say work done, it is a product of force, and when we say force, we are talking about the act of pull or push. That is the definition of work, or how work it is. Work, it is either you use a pull, you pull it, or you either push it with your hand or with something, you push it. That means you applied your force at that object or at that particle. So work done is defined as the product of the force and the displacement in the direction of the force. That means that the force that you are using is in that displacement, or it is in that distance. The displacement has to be in the direction of the force for that work to be done. So like maybe an example for a work, that kind of work to be completed or to be done, the force has to be in the direction, the same direction of the force. That is for the displacement. Okay, so let me give you an example. Maybe if you look at this picture, this diagram, you will see that a man trying to he is touching an object or a block. So if he touches that, this kind of, maybe let's say a box, it is a box, he put his hand on them, but that force is not in motion. And when we say it's not in motion, we're talking about it is not in moving. The object is not moving. So any kind of art of work that you are doing, even if you apply your force to it, if that object or that particle is not moving, that means that the work is not done. So that means that that work has to move for that work to be done, for you to have done that work. Okay, if you look at this second picture or this second diagram, you will see that a man carrying an object, maybe let's say a man, he is carrying an object. So even if you are carrying an object, and if that object is even heavy, is too much heavy for you, and even if you remain for some hours standing in the same position, in the same place, you are not moving, even that load that you are having is trying to reach you, you are about to fall down, and you think that you are moving. So in physics, that work is not done. For that work for you to be done, is that if you carry that object and move to some distance, the displacement, that means that that you use that force of yours and move that object from one position to another. That work has been done. If it moves from one place to another, that means that that work is complete. That is the work done. So any kind of force that you apply to that object, and if that object is not in motion, that work is not done, is not complete. You only do the work, but the work is not done. So in physics, work done is defined as the force times the displacement. If you look at this formula is for work. The W stands for work, and the F is stand for force, and the S is for displacement. That means that we are talking about the distance, how you displace it from one place to another, and that work is done. And this formula is meant for work. That is, W is equal to F times S, and that S is a displacement. So, and it has a SI unit, the SI unit for the work. So that NM, that okay, that N, yes, that NM, the capital M, and the small n. So this capital N stands for the Newton, but this Newton normally is for the force. That is the unit of force. So force is in Newton, but the S, the displacement, is in meter. The meter, the distance covered, that is the distance, that is the displacement. So the S is in meter. That is why, that is how it comes to this NM. That is Newton meter. That is one of the unit of work. So a work, it has two units. That is the Newton meter or joules. That is J. So you can use small j or capital J. That is, you mean that it is joule. So normally force has a Newton meter or a joule That is the SI unit for work. And normally in physics, work done is defined as the product of the force and the displacement in the direction of the force. That means that that work has to be in that direction. You have to have that force that you apply, that force that you are using has to be in motion. And when we are talking about motion, we are talking about the movement, the changing from one place to another. That is motion. It has to change, because if it did not change, that means that the work is not done. So that is the formula for work done, and that is the concept how the work done is. So normally work is everyone most of us used to do work. So only if you apply your force and you do the work in a distance, it's a distance covered, that is the displacement. That means that the work is done, and the formula for the work done is, as you are saying it, like this. That is, the W is equal to the force times the displacement. That is the formula for work, and the formula for calculating work done. And it has up to SI unit, the Newton meter or the joule. So that is for concept of work. Okay, so let's look at this example. So the example says, if you lift a 5 Newton load 10 meter in the air, what is the amount of the work done? So if you look at this example, you will see that you have to see and look at it. What and what are you given? Then you have, if you have 5n and the n is talking about force. So that means that you have your force. The force is given, and we have 10 m, and this m normally stands for the meters. So that means that we have our s, that is the displacement. So the only thing that we have to do is to put our own formula for us to find the amount of the work done. So normally our own formula is the w is equal to force times the displacement, that is the f times s. So if you put your force, the value given for the force, the load that you carry, the force that you apply is the 5 newton multiplication or times the meter, the displacement, that is 10 m, that is 10 meter. So if you times it together, if you multiply them together, we will have our own 50 joule. That is the amount of the work done. And this 50 joule, we can also change it into 50 newton meter, because if you look at it, we have 5n and 10m. So we can use we can make it into 50 newton meter, or we can leave it like this, that is 50 joule. So they are all the same, it is all the unit of work done. So this is for the example of the work done. We have our own values and put them into the formula and find the amount of the work done, the work that has done. So this is the formula for finding work done. So the second context of physics for the SS1 lesson is the concept of energy. Okay, so energy, normally energy, most of us know what is the energy that we are using to do the work. So you see they are related, the energy that we use for our work to do. So normally energy is the ability for us to do that kind of work, or the capacity for us to do the work. So energy in physics is the capacity for doing work. So you see, if you have the ability to do that work, that means that it is energy that you use. So you see, so energy is the ability to produce a change in motion or position due to a force. So you see, it is a changing, it's just a changing in motion or position due to a force, due to that kind of power that you have, that you apply, due to that kind of force that you apply to it. That is why it will change. So energy is the ability to produce a change in motion or position due to a force. So that is the concept of energy. Energy also is the capacity for doing work. It is also meaning of energy. It's all the same. So energy is the ability to produce a change in motion or position due to a force, due to that force that you apply to it. And the energy normally is measured in joule. So you see, the work and the energy are going hand in hand. They have the same unit. So also energy is measured in joules. That is J, the capital J or the small j. So it is the SI unit of energy. So the living organism, that is us, that is we. So we have to use our energy for us to live, or to do some functions, or to do some activities. So we need some energy. Also, like the technology need energy more than us, because if there is no energy, that means that there is no technology. So the technology also, they need energy to function, or for them to perform well, or to even have a development in technology. Because if there is no energy, that means that there will not be a technology. If there is no energy, the technology will not exist. So the entire cosmos is composed of energy and the matter. And when we say matter, we are talking about anything that has mass and can occupy a space. So that is energy. That is the concept of energy. And it may exist in the potential kinetic, thermal, electrical, mechanical, nuclear, or various form. That is energy. The energy, it can be into different form, because we have different kinds of form of energy. We have the mechanical, we also have the it can be the potential, that is the potential energy, and the kinetic energy. It can be thermal energy, or it can be electrical energy, or it can be mechanical energy, nuclear energy. So there's different kind of, it can come into a different kind of form. And we also have a sound energy, because it is also another different form of energy. So you see, energy can come in a different form, in a different ways. So that is the concept of energy. And also it is measured in joule, and also is the ability or capacity to do work. For that work to be done, we have to use the energy. So energy is the ability to produce a change in motion or position due to a force. So you see, that is the energy, that is the concept of energy, and it can come into different form. It has many forms. So this ones are some form of it. So this is the concept of energy. And this is a small picture of the energy. So this is how the energy is look like. Okay, so we are done with the work, energy, and the one that remains is the power. So the concept of power. Okay, and normally power, when we say power, we are talking about the quantity that has to do with the rate at which a certain amount of work is done. Is known as the power. So when we say power, we are talking about the amount of work is done. That is the power. At which rate, at which rate the work is done. That is normally power. At which certain rate the work is done. That is power. The power is talking about the rate at which the work is done. That is power. So if you see, they are all together, the work, the energy, and the power, they are all going hand in hand. So the concept of power is the quantity that has to do with the rate at which a certain amount of work is done. Is known as the power. So power is talking about at which rate the work is done. So power is measured in watts. That is their differences. So those two, the work and the energy, they have the same unit, but power, it have her own. So power is measured in watt. That is in watt, and it can be into many watt. It can be into 1 kilowatt, or megawatt, or watt per hour. They can be many. So that is the concept of power. And also power have our own formula or way to calculate power, to know at which rate, at when the work is done, at which rate, by which rate the work is done. That is power. So normally power is equal to the work divided by time. That is power. That is as simple as that. For you to find power, you are to just divide the work divided by time, divided by the time taken. That is power. That is normally the formula for power. So power, it can stay like this. So also, if you want to expand it, then you have to say, then the work, then because work, it has our own formula. And for normally, work is the first time the displacement. That is work. That is the F times the D, and okay, the S, that is the displacement. That is power. And the T is the time taken. So if you look at it, you expand it, because you expand the work, you expand it. And also, if you can expand it, that means that the force times the displacement all over time. That is also power. This one also is also the formula for calculating power. If in calculating, you have your force, you have your displacement, and the time, that means that you can also calculate power. That also means that if you have only work and you have the time, that means that it is work divided by time, you can also calculate power. And again, if you have force times the velocity only, that means that also you can also calculate power. So if you look at it, normally power, it have it have some formulas. It have like two formulas here. We have two formulas here for power. The off one that says the work done divided by time, that is also formula for power. And also the one that says post times the velocity, also it is also formula for calculating power. So it depends on how the question of how to calculate the power come, because there is a situation that you will have force and the velocity only. There is no the work. So you see, it's talking about the force and the velocity. You can have your own you can have that situation. Also you can have the situation that says only define power when we have the work done at so numbers, or at 10 divided by the time taken divided by 5 maybe. You will only divide by, you only do the division of work divided by time. That you will have your own power. That's it, as simple as that. And the unit of power, because unit is very very important in physics, so you have to consider unit. So it is in what? So the unit for calculation power, for you to know the power at which rate the work is done, you have to use the watt, because watt, it is a unit for power. So you see, we have some two formulas here, and it and there is a situation that you will only have force and the velocity, and in that situation you have to use this formula, the one that says power is equal to force times the velocity. Or if you have only work and time, you will have to use the offer one, the one that says power is equal to work divided by distance. So if you look at it, we have two formula of calculating power here. So let's go and see. So here there are some other common unit for power, and you see power, it can, the first one that we have is 1 kW, and this 1 kW stands for 1 kilowatt. And this W, wherever you see this W, it stands for watts. Yes, because it is in power, so it stands for watt. Also this 1 kilowatt is equivalent to 1000 watt, because it is in K. That means that it is in kilowatt. That also means that 10 to the power of 3 watt. That is the common unit for power. And if you look at the second one, that says that have 1 MW, and this 1 MW stands for 1 megawatt. It stands for 1 megawatt. And this also 1 W or 1 megawatt is equivalent to the mega to the power. And you can have your these zeros for the mega that has to the power of 6. That is mega. So whenever we are talking about mega, we are talking about to the power of 6. That is in the mega. So the 1 MW, that is the 1 megawatt, is equivalent to 10 to the power of 6. You can remove the M, because it is mega. But if you remove it, you have to put MW. You are talking about, if you remove the MW, then you are talking about the megawatt. So that is for the other unit of watt. We also have 1 HP. So this 1 HP stands for 1 horsepower. So this 1 horsepower is equivalent to 746 watt. So this is some other unit of power. Okay, and let's go to some. There is example here for calculating power. We have to calculate the power, and the example says a car is moving at a constant speed of 20 meter per second. The force retarding its motion is 500 N. That is Newton. Calculate the engine power of the car required to maintain the motion. Okay, again, let's go to the questions and see what and what and what are we given, what and what and what we have in the question. Okay, this one is said we have a speed of 20 meter per second. And if we can recall, if we can identify when we are talking about the speed and also the unit meter per second, so you see that this one is talking about the force, because we are talking about the constant speed. The car is moving at a constant speed of 20 meter per second. So that means that we have force. Okay. Okay, no, sorry, this does mean that we have the distance covered, because it is in meter per second the speed. I forget about this one. I'm talking I thought it is the distance covered, the s or the d. So the n, the one that have n, is talking about the force, the one that have newton, because newton is meant for force. The force is talking about the force times the acceleration, that is the force. So the 50 newton is for force, and the speed for the velocity, the one that have velocity, is talking about the meter per second, because whenever we are seeing meter per second, it's meant for velocity, and if it's meant for velocity, that means that it's for the distance. So that is what we have here. And if we have this value, so we have to see how which formula are we to use, in order to calculate this power, because they say calculate the engine power of the car required to maintain the position. So if we can recall our formula, the one that have power, that is P is equal to force times the velocity. So if we can record it, because if we look at this value, we don't have the work, because power is equal to force. No, power is equal to work divided by time. So we don't have a work done here, and we don't have the time. We only have the speed of 20 meter per second, and that is the velocity, and the 500 n, that is 500 newton. So this one also have a force. So if you look at this, if we can go back, so you see you have to use the second formula, the one that says force times the velocity. So we have to use this formula for us to calculate the power. So if we can put our formula, normally power, it says the force times distance moved per second, and this distance moved per second is talking about the velocity, because it is in meter per second, the constant velocity that it moves, that car is moving with, because it is the velocity that car is moving. So you see we only have the force and the velocity for those value given in this example, and if we can just put our own value and press our own calculator, and I assume that you have your own calculator, you have to press it and calculate and see. Okay, and let's press it and see. So our force is here. If we put our force, that means that this 500 n, that this 500 newton multiplication or times the 20 n m for s, that is the meter per second for the velocity, because when we are talking about the meter per second, we are talking about velocity. But if you are talking about meter per second square, that is for the acceleration. So we are talking about the velocity here, and we have to use this formula for us to find that force. So if we press 500 times the 20 meter per second, we will end up with 10,000 watts. That is the power that engine required to maintain the motion. For that engine to maintain its motion, the power has to be 10,000 watts. So that is for the calculation of the engine power of this example. And also, if we can short it and just make it into 10 kW, that means that this K stand for the kilo, is stand for kilo. So that means that our answer have to remain, we can leave it in that the second one, or we can leave it at the third one, at the third calculation. So each and every one of them is calling because you put O. It can be it can either be this one or it can be this one. So the power that engine required to maintain the position is 10 kilowatt. So this is the calculation or the formula that we use to calculate the power, because I told you there's a situation that you will be given a different kind of example, because you can use this one formula or you can use the other formula. Each one you have to look at the values, what are you given, for you to find what you are asked to find. So that's the calculation for the power. Okay, let's talk about the interchangeability of work and energy. So this, when we are talking about interchangeability of work and energy, we are talking about the exchange of work and energy, how they come to be related. So work and energy, they are somehow to be related, and they can be they are interchangeability. So the number one interchangeability of work and energy is work and energy are closely related. When you do work to move an object, so you see you do work to move an object, you change the object energy. So that means that you use your energy and change that object. So you see you extend energy to do the work. So you see that you have to exchange your energy for that work to be done. So you see the work and the energy, they are interchangeability, they are related, because you do work to move an object, and if you move that object, that means that you do work. If you move an object from one place to another, that means you do work, because you move it and you use your force to move it. So, and you change the object energy, also you expand your energy to do the work. So you see they are going hand in hand. That is the number one reason. So the second one is that the work and the kinetic energy are interchangeable. So they are the same because they have the same unit. And if you can recall, the work and the energy, they have the same unit because they are both measured in joules, because work is measured in joule and the energy it also measure in joule. So you see they are going, they are exchangeable. So there can be interchangeability between them, between the work and the power, between the work and the energy. They have the same unit. So that is the second reason. Also, work and the energy theorem stated that the net work done by the forces on the object equal to the change in its kinetic energy. So you see the net work done by the force, by that force that you use on an object, is equal to the kinetic energy. So you see, if you do this one, that means that you do this one, and if you do this one, that means that you do this one. That is mean that you do the work and the energy, and to do the work you do your energy. So you see both of them, they are related. That is the interchangeability of work and the energy. They are exchangeable. They can be interchangeable between them. Interchangeability between them. So that is how they come to be related. That is how they are somehow related, but they are not completely related. But they have some reasons to be related, to be interchangeability between them. So also for the determination of work, energy, and the power, because work, energy, and power are the fundamental concept of physics. Because without work, energy, and power, there is no physics. So it is they are the fundamental also concept of energy, because work is the energy needed to apply to move an object to move an object a particular distance. Also, power is the rate at which that work is done, and also the work and the energy, they have the same unit, that is the joule. They have the same unit, and both of them, they have their own formulas for calculating. And when we are talking about the determination, we are talking about how to calculate the work, the energy, and the power. And they have their own unit, but these two, they are in common. They have the same unit. They have the same unit. That is the joule they have. But the power is measured in watt. It can be in kilowatt. It can be in megawatt, because it can also be in horsepower. That is the power. It is measured in watt. That is the determination, because they have their own formula, and if they have their own formula and they have their own SI unit, that means that you can be able to find the work, the energy, and the power. And also they are the fundamental concept of physics. So by the grace of God, we have come to the end of the lesson for the first week physics lesson or physics class. So I wish you best of luck. I wish you good luck. Thank you for listening.